This video is about what's called probability models. All right. So one way that we see probability models is through the use of this thing that's called a two-way frequency table. And it's a table that displays frequency of data in two different categories. Sometimes they're going to call this a contingency table. But it's, kind of a good way to involve more than one, in this case two, different kinds of data that you could gather. All right. So in this first problem here, it says the table shows data about student involvement in extracurricular activities at a local high school. What is the probability? There's my first keyword, probability, that a randomly chosen student is a female who is not involved in extracurricular activities. So I've got a female, so I know that I'm looking at this line right here. I've got someone who is not involved in extracurricular activities. So that would be this column right here. And what I'm specifically looking for, because I'm dealing with probability, is where is success? Well, success is going to be right there where the two overlap. All right, where female and not involved in activities overlap. So to figure out this probability, it's actually pretty simple if you can read the table. So the probability is going to be 120. That's my success. Remember again, probability is success over total. But now I got to figure out what my total is. All right. In this particular case, my total is not going to be 265, which would be the total of not involved in activities. It's not going to be 259, the total of females, but it's going to be the total overall, which would be 516. Now, what I'm going to do on this video too is take these, and instead of simplifying the fraction, we're just going to change them into a decimal. So if I grab my handy dandy calculator, I have 120 divided by 516, and that's going to give me 0.233, 0.233. And the reason why I rounded it to 3 decimal places is because a lot of times they're going to ask you to write this as a percentage as well. So if I have that third decimal place, okay, the thousandths, I know that this would round to 23.3%. Okay, so let's take a look at another example here. In this two-way frequency table, you're comparing male and female students by grade level on the prom committee. What is the probability? So I know I'm doing success over total. That a member of the prom committee is a male who is a junior. So my males would be that column. My juniors would be that column. All right. And I know that the two of these are going to meet right there. There are 3 male juniors out of how many total people? 12. So the probability here is going to simply be 3 over 12, which would be 0.25. I didn't need a calculator to figure that out. All right. So let's take a look at a second scenario here. It says the probability an event will occur given another event has already occurred is something that is called a conditional probability. It's based on some condition occurring. Okay. So typically the way that you're going to see this is it's going to be written as the probability of B given A. So notice again, the key word here is this word given. So let me show you in a problem what we're talking about. I got this two-way frequency table. The respondents of a poll were asked whether they were for, against, or had no opinion about a bill before the state legislature that would increase the minimum wage. What is the probability? There's my key. First of all, I know I'm dealing with probability that a randomly selected person is over 60 years old, given that the person has no opinion on the state bill. So right here, given tells me I'm dealing with what's called a conditional probability. Okay? So I know I'm finding the probability, but now it's conditional. They want me to figure out what is the probability that it is that you are over 60 years old given that, remember that's what that symbol right there, that vertical line right there means, given that they have no opinion. Now, it seems like semantics a little bit, guys, but this actually really condenses what we're looking at. So the way that we're going to approach this is we're looking at the over 60 column again, or row. We're looking at the no opinion, so it's just like we were doing before, except now when I look at this, I'm going to say, okay, I know that the success is going to be 40, but the given that there's no opinion is actually telling me what my denominator will be. What is that total? So this 100 becomes the denominator, and that 100 was right there again. And then I can reduce this to 0.4 or 40%. All right. So let's see. I might have to shrink this a little bit. So this one says, I'm going to have to write it. What is the probability that a randomly selected person, stop for a second, probability, randomly selected person is 30 to 45 given, there's that key, telling you it's conditional, that the person is in favor of a minimum wage bill. So I'm going to do this one in blue just so we can use that same table there. This is a probability of 30 to 45 given that they are in favor. Or I'm just going to write they are for the minimum wage bill. All right. So if I come back up to the chart, I'm going to erase what I already have there just so we can see it hopefully clearly. If I can figure out how to make my pen work. There we go. All right. 30 to 45. We're talking about that group, that row right there. Okay. Those that are for, we're talking about that row right there. All right. I know that my success is right there at 200. And I know that my total is going to be the total for. Why? Because that was what I used for the given. So it's 200 over 780. And that would be, let's do it, 200 divided by 780, which would be 0.256. Okay, our third scenario that we're going to look at is using something that is called relative frequencies. All right, notice how the table is very similar, but instead of them using actual numbers, they're giving us frequencies. A frequency is simply like a decimal or a fractional part. Okay? Now, the company has 150 sales representatives. What does that mean? That one for the total on my table is really 150. And then this 48, this 0.48, would actually be found by figuring out how many people there were out of the 150 in increased sales, blah, blah, blah. Okay? Here's the beauty. Even though they give us relative frequencies, I don't have to worry about all that. I have to read the problem, though, carefully. It says, 2 months after a sales seminar, the company vice president made a tale of relative frequencies based on the sales result. What is the probability that someone who had attended the seminar had an increase in sales? Now, this is really hard to see, but there is a given statement in there. The word given is in there. They had to have attended the seminar is the given part. So this probability would be, what is the probability that they had an increase in sales given that they attended? All right, so how do we figure this out? Same way as before. Increase in sales, attended the seminar. All right, where do they intersect there? At 0.48. And that's going to be 0.48, though, out of my total, which is the total attended, or 0.8. And then if I simplify 0.48 divided by 0.8, hopefully you guys know that's 0.6. or 60%. All right, try one more here. What's probability the randomly selected sales representative who did not attend the seminar did not see an increase in sales? All right, this is another conditional probability. So I've got the probability that they saw no increase given that they did not attend. All right, no increase, did not attend. Let's come back up here to our table. All right, did not, let me make sure I got this, no increase, did not attend. All right, so that's going to tell me success would be 0.18 and total that did not attend would be 0.2. And 0.18 divided by 0.2, well, that would give me 0.9 or 90%. All right, I hope this helps. Let me know if you have any questions.